Under root x square minus a square dx. This is equal to x by 2 under root x square minus a square by 2 log modulus inside this bracket x plus under root x square minus a square. Now what is the proof? How did we get or arrive at this result? Now we are going to prove it for you. So before we go ahead, there are certain things. Integration of u dot v, that is u is the first function, v is the second function. When you integrate this, what is the result? The first function will take as it is. If you assume u and v are the first and second function respectively, u integration of v dx minus integration or differentiation of the first function, which is d by dx of u, and then the integration of v dx. When all of this is done, this will be integrated again. Okay, so this I will be equal to integration of under root x square minus a square. Now the problem is how we are going to go about it. We'll do it by parts. That is, we'll assume that it is multiplied by 1. We don't have to assume, it is already there. 1 is multiplied by every term. And then what is the first function and the second function? So let's take I as the first function as u and the second function as v. So I'm applying this formula now. Under root x square minus a square. Then we have integration of 1 dx minus integration of d by dx of 1. Under root x square minus a square. And then integration of 1 into dx. And then after this, we'll have the final integration. So what are we going to get here? 1 into dx will give you x. And then x square minus a square is unchanged. d by dx of under root a square, x square minus a square, I'll just tell you now. 1 dx will give you x. So let me write it here. I'll just combine it with d by dx of under root x square minus a square. So remember, this is 1 dx is x. Now this is very important. So I'll just do it in a side. D by dx of under root x is 1 by twice under root x. When you differentiate d by dx under root x square minus a square, it is going to give you 1 by twice of under root x square minus a square. That is very well known to you because you have done already the differentiation part. So d by dx of under root x square minus a square, as I told you, d by dx of under root x is 1 by twice under root x. So d by dx of under root x square minus a square is 1 by twice under root x square minus a square. And then we have to differentiate x square minus a square. That will give you 2x. So now this is 2x divided by 2 under root x square minus a square. I am cancelling 2. So you have x by under root x square minus a square as the differentiation. So I'm not writing x upstairs. I'm just writing under root x square minus a square because x is what we got from here. But x was earlier integration 1 dx, if you remember. I told you. So this x and x combined multiplied will give you x square dx. Now I'm going to show you this integration of the second part separately. So it's x square by under root x square minus a square. We need x square minus a square upstairs. For that you have to add negative a square, subtract negative a square. So just subtract a square and then you have to add also because you are doing it by yourself. Now separate these two terms out. X square minus a square divided by under root x square minus a square will be the first term because we are separating these two terms. And then we have a square divided by under root x square minus a square. I am taking a square outside the integral side. So 1 by under root x square minus a square remains inside. So this simply can be explained by x by under root x. This will give you what? It will give you under root x only. Because it is x to the power half, x to the power half in the denominator, it goes up. It will be negative half, 1 minus half is half only. And anything to the power half is just root. It's just root x. So just making similarity or analogy, it's simply under root x, which is under root x square minus a square in this case. So x square minus a square comes here. Now a square comes outside. 1 by under root x square minus a square is already lying there. Okay. Now negative is already there. So multiply negative here. So both the terms is going to get negative. So we have dealt anything which is coming outside or after x under root x square minus a square. So let's write x square under root x square minus a square. Then you have negative under root x square minus a square. Then you have minus a square outside 1 by under root x square minus a square. Already then. Now you see there is already an I in between. This is I only. Okay, from where we started, this is I only. So we can just replace the middle term by I. And this one x under root x square minus a square remains unchanged. And this is negative a square, but there is a direct result for integration of 1 by square root of x square minus a square. What is the result? I am writing the direct formula. It's log modulus of x plus under root x square minus a square. Now let me write it again because my writing is very good as you see here. So log modulus x plus under root x square minus a square, this is the result. Now this negative I can be taken on the left, it will give you I plus I. And I plus I is going to give you twice I. An I for an I. Who told me this line? Tell me. Okay, now this is 2I. I'm not writing 2 because I'm going to take it downstairs. So let me write other things. X under root x square minus a square. I is already done. Minus a square log modulus of x plus root x square minus a square inside the modulus. Don't forget to write the modulus. Now this already had a 2. So I'm bringing it downstairs on the right. So it's 2 in the denominator plus a constant of multiplication. From here to here, that's your final result.